Hi students, welcome back to my channel. So this is the third session of Haloalkanes and Haloarenes. In this session, we are going to discuss about the preparation of haloalkanes. So in the preparation of haloalkanes, we can prepare haloalkanes by various compounds and by various methods. And actually in our syllabus, we have chosen three compounds from which we can synthesize the haloalkanes. The first one is the preparation of haloalkanes from alcohols, okay, and the second one is the preparation of haloalkanes from hydrocarbons, and the third one is the preparation of haloalkanes by halogen exchange method. Halogen exchange methods. So these three are very important, so we'll see one by one after one. So in the preparation of haloalkanes from alcohols, we have three methods. It depends upon the reagent, which reagent we use. So the first reagent we usually use using halogen acids. Halogen acids, that usually HCl, HBr, so all these ones, okay, HX in general, that is HX, okay, halogen acids. And the second reagent we usually use is the using phosphorus halides, phosphorus halides, that is PX, phosphorus halides. Usually PX3 and PX5 are there, trihalides and pentahalides. We'll see when we are discussing in detail. In the third reagent we use, that is using thionyl chloride, using thionyl chloride. These three are the methods or the reagents that converts the alcohols into haloalkanes. And in the case of hydrocarbons, so as usual, saturated and unsaturated, that is from alkanes, and the second one is from alkenes. We can prepare the haloalkanes. So we'll discuss them later. And in the case of halogen exchange methods, the commonly chlorides and bromides compounds are very much in the nature because they are good reagents. But in the case of fluorides, those are very reactive, and iodides where they are very slow reactive, hence those compounds are very less. But whenever we required iodides or the fluorides, so we can convert chlorides and bromides into iodides or fluorides. Those two are the methods. So if you are going to convert chlorides and bromides, that method, that is a name reaction that is known as Finkelstein reaction. Finkelstein reaction. So usually here we get the iodides from chlorides and bromides. And the second one is to get fluorides, we have a name reaction called Swarts reaction. Swarts reaction. Here we convert all chlorides and bromides into fluorides. These are the very important methods for the preparation of haloalkanes in our syllabus. We'll discuss one after one. The first one is preparation of haloalkanes from alcohols. In that, the first method is that we are using halogen acids. Halogen acids. Okay. H is for acids and X for halogens, HXs. So usually we use most of the times HCl, HBr also can be used. So here, so alcohols when they are reacting with HX, usually this reaction is just by heating with anhydrous zinc chloride. Here the catalyst is anhydrous zinc chloride is used. Zinc chloride is used, and here we are going to get haloalkanes or alkyl halides, RX. Alkyl halides are haloalkanes, along with the elimination of water. So this is one of the very common reaction. So that alcohols will be converted into alkyl halides or haloalkanes when they are treating with halogen acids in presence of anhydrous zinc chloride. So here usually we take the mixture of anhydrous zinc chloride and dry HCl and dry HCl. This is one of the very famous reagent we used to convert the haloalkanes into alcohols. This one is known as the mixture of anhydrous zinc chloride and dry HCl. This is known as Lucas reagent. This is one of the very important question for NEET, CET and also in board exams for MCQ and all these things. So here the mixture of zinc chloride and dry HCl is known as Lucas reagent. And the conversion of alcohols into haloalkanes using Lucas reagent. Using Lucas reagent is known as Gross reaction, or it is the Gross method. Gross is again a name of a scientist. It is known as Gross method. In this, we are using the dry HCl and anhydrous zinc chloride. So that is the Lucas reagent. The conversion of alcohols into alkyl halides using Lucas reagent is known as Gross method. So here we usually take let me take an example because we have general reaction over here. So I will take an example, that is methanol, CH3OH, methanol, when it is treated with HCl in presence of anhydrous zinc chloride, it is going to convert into HCl, that is CH3Cl, chloromethane or methyl chlorides, chloromethane, the elimination of water. So this zinc chloride, the Lucas reagent is for the conversion of chlorides, conversion of alcohols into chlorides, alkyl chlorides. Okay, we can see another examples, that is we can take the ethanol. Ethanol, when it is treated with HCl in presence of anhydrous zinc chloride, so we are going to get CH3 CH2 Cl, chloroethane, or the common name is ethyl chloride, chloroethane. Okay, this is very important because this Lucas reagent come again in the next chapter, that is alcohols. So using Lucas reagent we can convert into alkyl halides, and it is also having differences. So that is why it is used to differentiate between or differentiate among primary, secondary and tertiary alcohols. So usually tertiary alcohols easily react with the Lucas reagent and converts into alkyl halides. If you see the order of reactivity in alcohols, this is also asked in MCQs. Order of reactivity of alcohols for Lucas reagent is tertiary alkyl halides. Tertiary alcohols are more easily undergo reaction, and secondary and primary alcohols. So regarding this, we'll discuss in the next chapter because it is usually asked also in for 2 marks. Regularly it has been asked. Okay, so that is the Lucas reagent test in alcohols. We'll come to know how it reacts. Okay, it usually first this is the product, the the haloalkanes comes very easier in the case of tertiary alcohols, and it takes time for about 5 minutes in the secondary alcohols, and usually primary alcohols give only after heating. So by this method we can differentiate primary, secondary and tertiary alcohols using Lucas reagent. Lucas reagent, that is one of the very important topic. We'll discuss it in the when it comes to the alcohols. So by here, for the preparation of haloalkanes, you please remember what is Lucas reagent. It is the mixture of anhydrous zinc chloride in dry HCl, and in the process using Lucas reagent to convert alcohols into haloalkanes is known as Gross method. Okay, this is very important. And the second one, we are going to see the preparation of haloalkanes from alcohols using phosphorus halides. Using phosphorus halides. So usually phosphorus trihalides and phosphorus pentahalides are used. So that's why I write a PX3 or PX5. These two are very common. So let us first see using the phosphorus trihalides and then phosphorus pentahalides. Phosphorus trichloride and phosphorus pentachloride are more common, and we can also have the tribromides also. We'll see it. Okay, so that is in that the first one is using phosphorus trihalides. Let us see that phosphorus trihalides, that is PX3. So your first reagent we have is the phosphorus trichloride, that is PCl3. So this is the reagent. This phosphorus trichloride will convert alcohols into haloalkanes. So when alcohol reacts with phosphorus trichloride, it is going to give us haloalkane, that is chloroalkane here also, along with H3PO3, phosphorus acid. Phosphorus acid. So 3 chlorides. So here also we get 3. So here also 3 and 3H. It is balanced now. So alcohols react with phosphorus trichloride, gives us chloroalkanes with the elimination of phosphorus acid. We can write ROS because phosphoric acid also is most common. So you might have heard about that name, H3PO4, phosphoric acid. So it is H3PO3 phosphorus acid. This is the when the alcohols react with the phosphorus trichloride, it gives us chloroalkanes with the elimination of phosphorus acid. So if you see an example, let me take a methanol, CH3OH. When methanol reacts with phosphorus trichloride, it is going to give us methyl chloride or chloromethane with the elimination of phosphorus acid. Here also 3. So this is one of the very good reagent because using phosphorus trihalides or phosphorus trichloride especially, so we can convert 3 alcohols into 3 alkyl halides. So here the reagent we require very small, in this very small amount. That is why it is one of the economic amount. We get a usually huge amount of the product, about 80% of the product we'll get. Okay, that is why it is one of the economic method. So that's why it is one of the industrial method also, very useful one. So second one, like in the trihalides itself, phosphorus trihalides, we can also have the bromides. Phosphorus tribromide, PBr3. Phosphorus tribromide. The same way this reaction happens, but phosphorus tribromide is not naturally available. That is why we need to prepare first phosphorus tribromide, and from which we can synthesize the alkyl halides. So first the phosphorus is going to treat with the bromine. Okay, the reaction of phosphorus and bromine gives us phosphorus tribromide, PbR3. If you balance, usually phosphorus is available in P4, and phosphorus has three allotropes, as you know, that is the white phosphorus, black phosphorus and red phosphorus. Usually in this case we use red phosphorus. When red phosphorus is reacts with bromine, which gives us phosphorus tribromide. If you balance P4 Br3 into 4, that is 12 6. Okay, so here phosphorus, that is only for the preparation of phosphorus tribromide, our reagent for the conversion of alcohols into bromides. Okay, now this phosphorus tribromide will react with alcohol. Okay, PbR3. It is also same in the case of PCl3 as we seen. Here also PbR3 reacts in the same way. RBr, that is bromoalkanes, with the elimination of same H3PO3 phosphorus acid. So here also we need 3 because Br3 3. It is also one of the economic reagent. So alcohols react with the phosphorus tribromide to give us bromoalkanes with the elimination of phosphorus acid. If you see an example, I can take any example alcohols. Here I taken methanol, that's why I'm going to take here ethanol. CH3, CH2, OH, ethanol. When it is reacting with phosphorus tribromide, it gives us 3 molecules. Here also we need to take 3 molecules. One PbR3 reacts with 3 molecules of alcohols. Here we get CH3, CH2, Br, bromoethane or ethyl bromide, bromoethane with the elimination of phosphorus acids. Okay, this is a very common reaction. So both the phosphorus trichlorides and phosphorus tribromides react in the same manner to give us alkyl chlorides and alkyl bromides. So now we'll see the reactions of phosphorus pentahalides. We have only one example, that is phosphorus pentachloride. If you want, you can take the screenshots. Phosphorus pentahalides. Using phosphorus pentahalides, we have only one example, that is phosphorus pentachloride. Phosphorus pentachloride, PCl5. Okay, the same here also, alcohol reacts with phosphorus pentachloride, so it is also going to give us alkyl halides, RX haloalkane with the elimination of phosphorus oxytrichloride, POCl3 and HCl. Okay, here, so same, the alcohols when they react with phosphorus pentachloride, it gives us that is haloal, it is a chloroalkane. So here we have Cl, so same here also, chloroalkanes only the products. In general, haloalkanes, the chloroalkanes with the elimination of phosphorus oxytrichloride and HCl. Okay, if you see an example, methanol, when methanol reacts with phosphorus pentachloride, it is going to give us methyl chloride, or the IUPAC name is chloromethane, with the elimination of phosphorus oxytrichloride and HCl. Otherwise, you can also write another example, ethanol. You can take any alcohol, CH3CH2OH, that is ethanol. Okay, so it is going to react with phosphorus pentachloride to give chloroethane or ethyl chloride. Same phosphorus oxytrichloride and HCl. So here it is not that economic like PCl3 and PBr3. Here it is only one alcohol can react with PCl5. So one PCl5, one alcohol, one alkyl halide. But in the case of PCl3 and PBr3, that is economic because one molecule of trihalide can convert 3 molecules of alcohol into halides. Okay. Yes. Now this is about the phosphorus halides, trihalides and pentahalides. Now we'll have the last one from the alcohols, that is the using thionyl chlorides. Using thionyl chloride, SOCl2. So using thionyl chlorides also we can convert alcohols into haloalkanes. Let us see that method. So this one is usually known as Darzen's process. Darzen's process or Darzen's reactions. So where we can convert alcohols into haloalkanes using thionyl chloride. The using thionyl chlorides, if you convert alcohols into haloalkanes, this is known as Darzen process. This is also come in your MCQs, which is Darzen process. Okay, like so here alcohols, when they react with thionyl chloride, is going to give us here also the chloroalkanes, only the products. With the elimination of sulfur dioxide and HCl. Okay, here HCl is been producing and sulfur dioxide is a gas, and HCl is producing, and it is going to get neutralized using pyridine. It also acts as catalyst because this reaction has to be taken place in the neutral, neutral, or it is in the basic method, basic medium, because the HCl has as it is an acid, it has to be neutralized. So that is why pyridine acts as catalyst, and also for neutralizing the HCl, it is also neutralizing agent here. Okay, this reaction is known as Darzen's reaction or Darzen process, where an alcohol reacts with thionyl chloride in pyridine. It gives us chloroalkanes with the elimination of sulfur dioxide and HCl. Most of the times HCl is a dry HCl, it can be evaporated. If it is a liquid, it is get neutralized by pyridine, and it can be easily separated because it is going to neutralize. So neutralized salt can be easily separated out. So that is why this process is very important, because here we can get the pure haloalkanes or pure chloroalkanes, because both sulfur dioxide is a gas, it can evaporate, and HCl can neutralize, or if it is a gas, usually dry HCl will evaporate, and if it is a solution of HCl, that it will be neutralized with a pyridine and it is separated out as a salt. That is why we can get the pure chloroalkanes. Hence this method is very important to get pure haloalkanes, the Darzen's process. Okay, so here pyridine is used to neutralize the HCl producing in the, to neutralize HCl producing in the reaction. Okay. So this is also asked MCQ, what is the purpose or what is the function of HC pyridine in the case of Darzen's process? It is to neutralize the hydrochloride gas or hydrochloric acid. That is why it is important. And if you see an example, CH3OH methanol, when it is treated with thionyl chloride in presence of pyridine. Usually pyridine is written just as PY. Okay, it is an abbreviation of pyridine, PY. It is going to give us methyl chloride or chloromethane with the elimination of sulfur dioxide gas and HCl. So this is one of the very important method. We can get the pure chloroalkanes. So that is why this is about these three methods. That is one from the using halogen acids and using phosphorus halides and thionyl chlorides. So we can convert alcohols into haloalkanes. These are the three methods we have the for in your syllabus for the conversion of alcohols into haloalkanes. The second method for the preparation of haloalkanes, that is from hydrocarbons. So here both saturated and unsaturated like alkanes and alkenes will convert into haloalkanes. Let us see that. So that is one. First one is from alkanes. Okay, first one is from alkanes. Let me just discuss with an example that will be easier for to understand. So if I take this is butane. Okay, in butane, when it undergoes, usually chlorination is common here, chlorination and bromination. Chlorination in presence of UV light. So when I write UV light, you know the mechanism itself, right? Okay, or just by heating also it occurs. So it is going to give us the mixture of CH3, CH2, CH2, CH2Cl, okay, and CH3, CH2, CHCl, CH3. So that is the mixture of yeah, one chlorobutane and two chlorobutane. That is, we can also call it as primary chlorobutane and the secondary chlorobutane. So here the products are one chlorobutane and two chlorobutane. Here we cannot get a single product. It is very low. We can get the product yield. So chlorobutane, because this reaction is usually taking place in UV light. So this follows free radical method. You please remember, this is usually asked. Free radical mechanism. It involves free radical mechanism. I'm not going to discuss the free radical mechanism because we already discussed it in the first semester, first year. So these all come in the last year. Okay, from alkanes to we can convert into haloalkanes. That is, we already discussed in the last year. Okay, that is why I'm not discussing it much. Hydrocarbons. Okay, the more important, this is not much important here, but it is very important in the NEET CET because the NEET CET involves both the year's syllabus. So we already discussed in the last year. So please go through that, and it follows. You know that that is the three steps: initiation, propagation, and termination. So in the initiation, we are going to get the chlorines will convert into chloride radicals, and chloride radicals will propagate into the butanes, and it gives us the same butyl free radical and also chlorobutane. So the last step is all the chlorines and the butanes will convert into the hydrocarbons, and also the yield of one chlorobutane and two chlorobutanes, termination. So that is why we are not going to discuss the mechanism, because in the preparation we do not usually discuss the mechanism, but you go through this first year syllabus. So the second one is unsaturated hydrocarbons, that is alkenes. That also was there in your first year. So here just I am discussing for your knowledge. We already discussed these two reactions when we are studying the hydrocarbons chapters, the reactions of alkenes and the reactions of alkenes. So here an alkene, if you see an alkene, when it is you can have two methods here. The first one we can have hydrohalogenation, that we already discussed in the first year. Hydrohalogenation, that means this is the addition of hydrogen halides. Hydrogen halides. So it is very important there in the first year, because it was also asked in, it is regularly asked in the exams. You might have definitely gone through these reactions. So here, so this case, when addition takes place at alkene, so here one hydrogen will add to the carbon, double bonded carbon, and a halogen added to the another carbon of the double bond. So that is CH single bond CX. Here it is going to form a haloalkane. Haloalkane. Okay, this is one. If you see an example, yeah, alkene, I am going to take an alkene of CH3, CH double bond CH3, CH2, propene. Okay, I'll take an example of propene. When propene undergoes, you can add a HBr and also HCl, both can easily undergo this reaction, addition. So here we are going to get the mixture of, yeah, see, CH3, CHCl, CH3, 1, and CH3, CH2, sorry, CH2, Cl. So here 2, so that is 1, 1 will balance to HCl. Okay, here it is 2 chloropropane and it is 1 chloropropane. So here we get the mixture of 1 and 2 chloropropane, and as you all know, the 2 chloropropane is a major product and the 1 chloropropane is the minor product. You know why it is? Because you have studied in the first year. Okay, for your hint, I'll write here, it obeys Markovnikov's rule. Markovnikov's rule. So 2 1 is the 2 chloropropane is the Markovnikov's product, hence it is a major product. You know the Markovnikov's rule, right? In the addition of an hydrogen acid or any, sorry, halogen acids to an asymmetric or unsymmetrical halides, sorry, alkenes, the hydrogen atom will attach to the carbon containing more number of hydrogens, and the nucleophile attack at the carbon containing less number of hydrogens across the double bond. This is the definition or the statement of the Markovnikov's rule. You please go through the first year again. So here, that's why the 2 chloropropane is the major product. That's why I didn't take any saturated, like alkene, ethene I didn't take, because of we need to explain the Markovnikov's rule. Okay, so that is also there in your first year. That is very important. Please go through that method. So here also we need to take 2 because we have 2 methods. So here we can have another second one, BA. It is the B method is, here we added hydrogen and halogen. So that is the addition of hydrogen halides. We can directly add halides. That one is halogenation. Halogenation. That is addition of halogens. halogens. Here we are doing directly adding X2. Okay, halogens. So here, if you consider general representation, this is an alkene. When an halogen is added, so it is going to give us XX. Okay, so dihalides we are getting dihalides. The two we usually get the vicinal dihalides, dihalides, vicinal dihalides. Okay, yeah. If you see an example, so it is when alkene undergoes halogenation, that is the addition of halogens, it gives us vicinal dihalides. Okay, let us see an example. CH2, it is ethylene. Common name is ethylene and IUPAC name is ethene. When it undergoes halogenation, chlorination, it gives us CH2 chloro, CH2 chloro. That is 1,1 dichloroethane. It is one of the vicinal dihalide. So this is about the preparation of haloalkanes from hydrocarbons. These are not much important in the second year, but these were very important in the first year, both from alkanes and alkenes. That is why these are very shortly we are discussing in this topic. So if you come to the last year, it was very important and it is now important for NEET CET. Usually many of the times it is very less times, very few times it is asked in the board exams, CBSE or any state board exams. So that's why this was very important first year. Here also we can prepare the haloalkanes. That's why we discussed these two methods. The next method for the preparation of haloalkanes, here is not actually the preparation of haloalkanes. Already haloalkanes are there, but we need to convert them into fluorides and iodides, because fluorides and iodides are very less in numbers. Usually the bromides and chlorides are more in the numbers. So we can convert bromides and chlorides into iodides and fluorides. Those are considered as halogen exchange methods. So here we can convert chloroalkanes and bromoalkanes into iodoalkanes and fluoroalkanes. The first one in this case is Finkelstein reactions. Here we can convert chloroalkanes and bromoalkanes into iodoalkanes. So here, yeah, this reaction is usually having X. Usually X is for chloro and bromo only here in this reaction. So when this is reacting with the concentrated sodium iodide solution in presence of dry acetone by heating. Okay, when a chloroalkane or bromoalkane is heated with the concentrated solution of sodium iodide in dry acetone, it converts the chloroalkane and bromoalkanes into iodoalkane. Okay, the elimination of sodium halides, usually sodium chloride or sodium bromide. So here haloalkanes, here we only get the iodoalkanes. So this one is the very important reaction, because most of the times either Finkelstein or the Swarts reaction, where we can convert chloro and bromoalkanes into fluoroalkanes, will come definitely in your board exams, and also these are very important in the MCQs are also in the NEET CET. So here if you see an example, that is, let me take a chloride, methyl chloride, so chloromethane, when it is heated with sodium iodide in dry acetone, it gives us methyl iodide or iodomethane with the elimination of sodium chloride. Iodomethane. Okay. The same way, if you have bromide also, it can be converted into iodide. So for example, CH3CH2Br, bromoethane or ethyl bromide, bromoethane, when it is heated with sodium iodide in acetone, so it is going to convert into ethyl iodide, CH3CH2I. Iodoethane is the IUPAC name, plus sodium bromide. Okay, so this is the conversion of chloro and bromoalkanes into the iodoalkanes. This one is Finkelstein reaction. This is one of the very important reaction in the syllabus, because it is many times and regularly every year it has been asked, either Finkelstein or the next one, fluoro alkane preparation, Swarts. Second one is Swarts reaction. So here we can convert the chloroalkanes and bromoalkanes into the fluoroalkanes. For example, if you see, and here we are using only the one reagent, that is sodium iodide, and here we are using many of the reagents like silver fluoride or mercurous fluoride or cobalt fluoride, many etc. So here you can use many of the fluoride salts. So here these chloroalkanes, bromoalkanes, here first only it stands for only for chlorines and bromines. Okay, so that is an haloalkane. For example, I'll take an example of sodium. Sorry, this one is silver fluoride. Here it is going to convert into alkyl fluoride with the AgX, silver halide. So this is fluoroalkane we are going to form. Fluoroalkane. Okay, if you see examples, same methyl chloride, if you take, that is chloromethane, when it is treated with silver fluoride, there is an exchange of ions. Fluoride will replace the chloride. So here we are going to get CH3 of fluoromethane or methyl fluoride with the elimination of AgCl, silver chloride. That is fluoromethane. Okay. If you see another example, the second example, here CH3 CH2Br, ethyl bromide or bromoethane. It is going to react with mercurous fluoride. Okay, it is mercurous fluoride, Hg2F2. So here is going to, this bromoethane converts into the fluoroethane, CH3 CH2F. We have 2F, so let me take this 2. So it is going to 2 along with the elimination of mercurous bromide, Hg2Br2. Here we are getting the ethyl fluoride or fluoroethane. Okay, here these two are the very important. Either Finkelstein or Swarts will definitely ask in your exams, board exams, and there will be also every year a question on this topic in NEET CET also, and all competitives like NDA, JEE, all that. So that is why this is one of the very important topic. So that is why please go through that Finkelstein and Swarts reaction. You need to remember. So in the Finkelstein reactions, chloro and bromo alkanes will convert into iodoalkanes, and in the Swarts reactions, chloro and bromo alkanes will convert into fluoroalkanes. Okay, this is about the preparation of haloalkanes. So we have prepared haloalkanes from alcohols using three reagents. That one is the first reagent, that is halogen acids. The second reagent, that is the phosphorus halides, phosphorus trichloride, tribromide, and also phosphorus pentachloride. And also the using thionyl chloride, that is the Darzen's reaction. And the next one is preparation of haloalkanes from hydrocarbons, that was there in the first year syllabus. Here also we have seen that is from alkanes and also alkanes. Okay, and the last one is, this one is very important, that is the halogen exchange method, where we can convert chloro and bromo alkanes into iodides and fluorides. Okay, this is about the preparation of haloalkanes. So in the next class, next session, we are going to discuss the properties, physical and chemical properties of the haloalkane. To watch all my videos regarding haloalkanes and haloalkanes, previous two videos, there was first video about introduction and classification, the second video about nomenclature. Okay, and also the nature of CX bond. So you should know the nature of the bond, right? Thank you for watching, and please subscribe to my channel, share with your friends, and keep supporting. Thank you.